holidays coming up, a lot of people are afraid of gaining weight because of big Christmas dinners, and these Christmas dinners can happen repeatedly because we typically have a lot of friends and family. And so if you're afraid of this, intermittent fasting might be a good method for you to utilize to avoid the fat gain. The two studies that show this benefit of intermittent fasting, one of these studies was done in athletes. The athletic study can kind of show that intermittent fasting can really be beneficial for people that want to improve speed or agility because lower body fat is seen to help in those two areas. The thing with intermittent fasting is that while you are losing fat mass, you're not losing muscle mass, which is beneficial to athletes, as diets that involve caloric intake, so this is putting your body in a starving state, causes catabolism, so that's breakdown. So it's not only fat breakdown, but it's also your muscle breakdown, which would lead to a decrease in strength. Another way intermittent fasting can really be beneficial is on the other side of the spectrum, people who might have problems with insulin sensitivity or who might be obese. So in obesity, like a really detrimental thing that's seen is having a lot of visceral fat. And visceral fat is that intra-abdominal fat. It's really, really deep into your body. And this can be a problem in diseases because it can affect the way that your organs are functioning. So the first paper that we are going to get into did intermittent fasting with 34 male athletes. So half of these athletes were put into the control, so they were allowed to eat for 16 hours in the day, and the intermittent fasting group only had an 8-hour feeding window. So before and after that, they could not eat, so they were fasting for 16 hours in the day. They stayed on this regimen for 8 weeks, and their caloric intake wasn't reduced, so they were basically eating how they were eating before the study, determined by their body mass and their typical daily energy expenditure. In this study, things like body mass, body fat percentage, strength, and hormone levels were recorded. There was a significant decrease in fat mass that was seen in the intermittent fasting group, but there was no decrease in fat mass in the regular 16-hour feeding group. So that was the control. Interestingly enough though, there was no real difference between the intermittent fasting and control group in terms of the lean muscle mass and strength. The way that they measured strength here was by looking at the 1 rep max of bench press and leg press. And there was no significant difference between the groups. The intermittent fasting group maintained their strength even though they were only feeding for 8 hours a day. And in addition to this, they looked at the muscle mass, measuring the circumference of their arm and leg, and they saw that these values also stayed the same after the 8 weeks of intermittent fasting. An interesting thing here that I thought from the study that can really be applied to any kind of individual, doesn't matter if you're an athlete, was the hormone levels. In the intermittent fasting group, there was a decrease in leptin, and this is a hormone that is secreted by adipose, so fat tissue, and it signals your brain, basically tells you that you're full, kind of like a signal, just stop eating. The decrease kind of makes sense in the intermittent fasting group. In that 8-hour feeding period, you really could get hungry, but since you're restricted to only that time period, your body is more likely to use your fat stores in your body to compensate. An interesting side note here is that in obesity, leptin levels are found at very, very elevated levels. So in individuals with obesity, before they get to that stage, persistent eating can happen even once leptin is released. So yeah, your hypothalamus releases the leptin, signals feelings of fullness, but when you continue to eat, more of that hormone is produced. You get your body becoming desensitized to this, which would cause a dysregulation and malfunction in the actual effectiveness of the leptin hormone. Another hormone that they measured here was adiponectin. This is also secreted by your adipose tissue. So adiponectin is involved in glucose and fat metabolism, and a decrease in leptin, but an increase in adiponectin can stimulate beta oxidation. This kind of study opens up the possibility that maybe this is the pathway that's being impacted by intermittent fasting. So relating back to the holiday season, if you increase your adiponectin levels to get your body to kickstart that fat metabolism, that could be a really good way to get rid of the excess fat that maybe you've built up from stress eating because of knowing that the holiday season is coming up, or in the new year when you realize that you overeat too much and you need a way to get rid of it. So in this study, they used mouse models instead of human models. You can do invasive techniques on mice, whereas you can't do them in humans. So this study actually used every other day fasting instead of 8-hour feeding period. Every other day fasting, the mice are still getting the same amount of calories in both groups, but the thing is they get twice of their daily usually intake on the second day, and in the first day they are completely fasting. The problem with this is that there's a lot of different ways that you could potentially do intermittent fasting. It doesn't necessarily have to mean an 8-hour feeding window. When you compare these kinds of studies, that's something that you really should keep in mind. So this study really looks at the beiging of fat. Well, I'll give you a quick overview on what the difference between brown fat and white fat is. White fat is what composes most of your fat stores in your body as an adult. And the main purpose of white fat is to store energy for the future. So when you're doing exercise for long periods of time, your fat metabolism really starts to kick in. That white fat is providing the energy for you to be able to run a marathon, for example. Meanwhile, brown fat is used for something called thermogenesis. And brown fat is something that's really seen in animals that live in cold conditions, and it provides them with an adaptation to overcome the cold during the winter. Thermogenesis basically translates into generation of heat, and this is exactly what your adipose tissue does. It has a protein in its mitochondria, its inner mitochondrial layer to be specific, called UCP1. Another important mitochondrial membrane protein is called ATP synthase. ATP synthase is really how your body generates the gross amount of ATP, because in your mitochondria you have your intermembrane space, and this space has a lot of hydrogen protons, and this creates a gradient, and this ATP synthase protein can allow you to drive ADP, so that's old ATP you can think of, that the energy has already been sucked out of, back into ATP, and this is really driven by that proton gradient. So now the UCP1 protein is kind of stealing the protons from the gradient and letting it get into the matrix of the mitochondria, bypassing that, and you get lost energy basically. But this energy has to come out in some way, so it comes out as heat. So this is pretty beneficial to us or other animals if we are in the cold. Something that was found in the fasting mice in this study was that energy expenditure was increased, even though they were really just doing the same daily activity. What was causing this was the non-shivering thermogenesis because of the brown fat. So they saw an overall reduction in overall body fat in the fasting mice compared to the control group, but which is also consistent with the human study that we talked about earlier. Tying in with this, they also had no significant decrease in lean mass. Now, I just wanted to address the whole UCP1 thing that I mentioned earlier and what it means for intermittent fasting. So the phenotype that the researchers found in the mice wasn't purely brown fat, but it was something with the exact same ability, something that they call beige fat. This has the same ability because it has this UCP1 protein, which is seen by the elevated mRNA levels of UCP1 in the fat tissues of mice, which is indicating that intermittent fasting upregulates UCP1 protein, meaning that existing white fat is starting to convert into this brown fat, which allows it to undergo thermogenesis. The fact that you get more brown fat can be really beneficial to individuals with obesity or anyone that's trying to lose fat, because just going outside in the cold is going to be a way of you burning this fat. Now to address the obesity aspect of this study. So the researchers induced obesity into the mice. They fed them a really high fat diet for 3 months straight, and then they put them in the control free feeding. They could eat at whatever time they wanted, or the every other day fasting. The cumulative food intake was the same between the two, but the every other day fasting had a much faster decrease in body weights and an increase in GLUT4 expression. Glucose transporters are basically involved in helping the cells take up glucose after insulin has been released into the bloodstream, which happens after a meal. Insulin basically causes an upregulation of these glucose transporters in your cell. That can let glucose come in. Your cells will break it down through glycolysis, Krebs cycle, etc. to make all of the ATP you need. So relating back to the increased glucose transporter expression, this can really be impacted in people with diabetes or insulin sensitivity or obesity, because having an upregulation of this can increase the efficiency of your metabolism to break them down accordingly and get the ATP you need to feel energetic while not storing it into unnecessary fat. So in addition to weight loss and the upregulated glucose transporters, the previously obese mice also lost a lot of visceral fat in the every other day fasting regimen. A really big problem in obesity, as I mentioned before, was the visceral fat, and as seen from this image, you can see that the previously obese mice who were put on the fasting routine had a lot less visceral fat in their livers and a significant decrease in injury markers along with triglyceride levels in the liver, leading to a productive and functioning liver. So I think both of these studies hold a lot of importance because they show that intermittent fasting can benefit individuals with obesity and also healthy individuals that just want to keep their fat levels down. So over the holidays, if you're thinking about indulging into your Christmas dinner, just skip breakfast before you do and try to reduce that time feeding window so you can get all of those calories from your turkey dinner or whatever else it might be within a certain time window. So Merry Christmas, Happy Holidays, go treat yourself, just eat in a constrained time period. This is Nola from Metabolic Fitness. Thanks for watching.